Think of analytical problem solving as a practical playbook for turning messy situations into workable solutions. The moves are simple and repeatable. Clarify the problem, break it into parts, form hypotheses, test and iterate, then implement and monitor. Do these deliberately, and you reduce bias, learn faster, and make results more predictable. Start by nailing down the problem. Vague descriptions waste time. Ask, what exactly is happening, why it matters, who's affected, and what limits we're working with. Turn fuzzy goals into measurable targets. For example, cut customer complaints by 30% in 6 months. So you can tell whether you're making progress. Decompose the issue. Split it into smaller chunks using process steps, phases, locations, or stakeholders. Smaller units expose where things fail and let you apply targeted fixes instead of broad, unfocused changes. Work with a hypothesis-driven mindset. Don't try to test everything. Pick a few plausible root causes and run low-cost experiments to check them. Use the scientific method. Predict, test, observe, revise. That keeps effort focused and speeds up learning. Choose the right frameworks for the job. Root cause analysis, 5 whys fishbone, to trace symptoms back to causes. Pareto analysis, to find the few causes that deliver most impact. Systems thinking to map interactions and feedback loops when causes span components. Decision analysis, decision trees, expected value, sensitivity. For choices under uncertainty. FMEA to list failure modes, rank severity, and prioritize mitigations. Controlled experiments and A/B tests for measurable changes. Design thinking, when the problem is ill-defined or UX matters. Use practical tools to structure thinking and communication. Flowcharts to map processes. Dashboards to track KPIs. Cause and effect diagrams to organize drivers. Data visuals to spot trends and outliers. And checklists to ensure repeatability during rollout. Be rigorous about data quality. Check sources, watch for bias, validate assumptions, and beware of small samples or confounders. Mix quantitative analysis with qualitative insights. Interviews, observations, and expert judgment often reveal dynamics numbers miss. Iterate fast. Prefer small, reversible changes, measure impact, and refine. Document experiments so learning accumulates. For high-risk changes, use staged rollouts and a contingency plan. Watch common traps, fixing symptoms instead of the real problem, confirmation bias, analysis paralysis, and scaling unproven fixes. Counter them by keeping goals measurable, inviting dissenting views, setting deadlines for decisions, and running controlled pilots. Quick example. If late deliveries are rising, define the metric, % late. Break the delivery flow into order entry, picking, packing, carrier handoff, and transit. Hypothesize likely causes, picking delays, carrier shortages, wrong ETAs. Check timestamps to see where delays stack up, pilot a picking workflow change, and compare lateness before and after. If picking was the bottleneck, scale that change. If not, test the next hypothesis. In short, be clear, break problems down, pick and test smart hypotheses, use the right frameworks, guard your data, and iterate. That's how uncertainty becomes manageable and improvements stick.